The objectives of session 3 it is to write the auto-ionization equation of water and deduce the relation between the concentration of H+ and the concentration of OH-. To relate the acidity of a solution to the concentration of OH- ions. Pause the video to open up your booklet at worksheet 28. As a revision, pH is the measure of acidity or basicity of a substance. The pH value can range from 0 till 13. The pH which is equal to 7 is said to be neutral. The pH which is less than 7 is said to be acidic, and the pH which is greater than 7 is said to be basic. In an acidic chemical medium, the concentration of H+ is the dominant one, so it is more than the concentration of OH-. In case of a neutral one, the concentration of H+ is equal to that of OH-, and in case of basic medium, the concentration of OH- is greater than the concentration of H+. Water and hydronium ion. An acid is any compound that gives H+. This H+ produced reacts rapidly with water because it's unstable. According to the equation, H2O plus H+ gives H3O+. Water, when added to H+, the number of hydrogen atoms 3, and it will be positively charged. This ion is called hydronium ion. An example about the acid HCl. It ionizes in water and gives H+ and Cl-. However, H+ is unstable, so directly it reacts with water to produce the hydronium ion H3O+. Upon adding these two equations, H+ would be removed, so the remaining will be HCl plus H2O gives H3O+ and Cl-. This is a reaction between an acid and water. Note that the concentration of H3O+ is equal to that of H+. In the ionization equation of an acid, we can write this simple ionization equation, or we can add this one. Is pure water neutral? In fact, this is true. Pure water is neutral. However, water can act sometimes as acid by donating a proton or as a base by accepting a proton. Auto-ionization of water. To begin with, a water molecule that loses a hydrogen ion becomes a negatively charged hydroxide ion OH-. So upon losing a hydrogen ion, it becomes negatively charged and the number of hydrogen would be 1, resulting in OH-. And this water molecule accepting H+ will be H3O+, so it's a hydronium ion. Auto-ionization of water. It is the ionization of water into the ions OH- and H3O+, represented by this equation. The pH of pure water is equal to 7. So the concentration of H3O+, which is the same as H+, can be calculated as 10 power minus pH, resulting in 10 power minus 7 molar. But pure water is neutral, so the concentration of H3O+ is equal to the concentration of OH-. Therefore, the concentration of H3O+ will be the same as OH-, equal to 10 power minus 7 molar in case of water. So if we want to calculate the ion product of water, which is the product of concentrations of ions in it, it will be 10 power minus 7 times 10 power minus 7, which is 10 power minus 14. This value is constant at constant temperature 25 degrees Celsius. So the ion product of water can be calculated using this relation, and this relation could be used to calculate the concentration of H3O+. If the concentration of OH- is given, it will be 10 power minus 14 over the concentration of OH-. And also we can calculate the concentration of OH- if the concentration of H3O+ is given by dividing 10 power minus 14 over the concentration of H3O+. Another rule for pH is derived from the logarithmic function. It is pH equal 13 plus log concentration of OH-. So, to find pH, you should search either for the concentration of H+ or the concentration of OH-. If the concentration of H+ is calculated, we use the rule pH equal minus log the concentration of H+. If the concentration of OH- is calculated, we use the rule pH equal 14 plus log the concentration of OH-. Now open your booklet at worksheet 28, pause the video and try to solve application 1. In application 1, it's given that the concentration of H+ is 10 power minus 2 molar. It's required to calculate the concentration of OH-. As we said in the explanation, the ion product of water could be used in this case. The concentration of OH- is equal 10 power minus 14 over the concentration of H+. The result will be 10 power minus 12 molar. Now pause the video and take a look at application 4 and try to solve it. In application 4, it's given that we have 3.4 gram of H2SO4 in 100 milliliter water. What's the equation of dissociation of H2SO4? Simply, H2SO4 in water, it ionizes into 2H+ and SO4 2-. And this ionization equation, surely it's a physical change because we don't have a change in the identity of matter. What about the concentration of H+? To calculate the concentration of an ion, as we said before, we refer to the stoichiometric relation in the ionization equation. We have the number of moles of H2SO4 over 1 equal the number of moles of H+ over 2. But the number of moles of H2SO4 can be calculated using mass over molar mass, so the answer is 0.0347 mole. So, the number of moles of H+, it's equal to 2 times 0.0347, the result is 0.0694 mole. What about the concentration? The concentration is calculated using number of moles over the volume, and the answer is 0.694 molar. Don't forget to transfer the unit of the volume from milliliter to liter by dividing by 1000. Part 3. What about the pH? Because we have calculated the concentration of H+ before, therefore we use the rule of minus log concentration of H+. So it will be minus log 0.694. The answer is 1.159. A final conclusion. Auto-ionization of water, it is represented by the equation 2H2O gives OH- plus H3O+. The ion product of water, it is the product of the concentration of H3O+ multiplied by the concentration of OH-, and it's equal to 10 power minus 14 at constant temperature 25 degrees Celsius. The pH can be calculated by using the relation 14 plus log the concentration of OH-. As an assignment, you have to study the related notes in worksheet 28, page 76, and solve the applications 2, 3, 5, 6, 7, page 77, 78.